Okay, I think before we start, let me just remind you something about the schedule of our exam. So as I mentioned in the last post Moodle like yesterday, that probably next Wednesday will be quiz, offline quiz, and the final exam will be the next week. So it's going to be 28 or 29. But we can also make the exam earlier if you want, like in the 22nd. So precisely next week. So this will be the last day of the course. It can be. It's up to you. Which schedule do you want? Yeah, definitely. Yeah, which exam you want to take? Both are, yeah. For me, it's okay because I already designed the questions. I just finished. Yeah, I'm waiting up for the final, final polish of the questions.
Maybe you can share this question.
So I would like to know, do you agree if we have final exam on 22nd? 22nd? Okay, 1, 2, 3, 4, 5. Okay. So what will be the rest of you? 28 or 29? Do you agree with that?
A poll somewhere.
Hmm?
Like a poll, a vote.
Okay, okay. I can make a poll after the class. Okay. Okay, or later I will put inside the feedback, the Mentimeter. Okay. So anyway, the last part of our class, we still in the improper integral. Okay. So let me give you a little bit review. Okay. So we have now type 1, which is having infinite intervals. And then for the second type, which we are going to discuss on today's class, is when we have a discontinuous endpoint or integrands. Okay. So let me write the sections as type 2, discontinuous integrands. Integrands mean the endpoints of the integrations. Okay, now let me give you a little bit illustration what it is here. So imagine we have a point that is in x equal b. That's our, we call this in our limit, this is we call as an asymptote, right? The vertical line. So when this t going to approach this b, or let's say we could say that if f continue on interval AB, okay, and we need to write down that this is having this continuity at B, let's say that, and then we could write that the integration from a to b of f of x dx, this will be equal f of x dx. So it means that we are going to limit our dummy variable t, okay, approaching b from the left. Okay. So from here, if you remember the limit concept. Okay. So this is what will happen when we have this continuous point. The previous type, we have the t is going to be infinite. But now, the t is going to the point where the discontinuous happen. Okay. Oh, it's not. Sorry, the interval should be b is not included, because if it's included, then it's impossible, right? Okay, so this is going to be like limit from the left. We can also have limit from the right. Okay. So let me set up the picture. We can also have this. So let's say now the problem is on A. The discontinuity is on A. Let me write here. If f is same, continues on, but the interval going to be different. This will be the interval. And discontinue continuity at A, then the integration from A to B f of x dx is limit as t approach A from the right. Okay. That's our t approach A from the right. So then we can take the integration with variable t to calculate this integration. And then we can take the limit. A, B. And then another statement on this type 2 is when we have this figure. So we have point C in between A and B. So this point C is also discontinuous. Okay. So if the functions has discontinuity at C, and then C is in between A and B, and both and this both converge, then we could rewrite that the integrations from A to B of f of x dx and then take limit for each part. Let me write first plus or maybe let me write first this and then You can write in the bottom. Oh, let me write with the red color. Then let me use another variable age to make it this difference. Okay, also this can happen. So in between of this, it seems like we have two area of AC and CB, but on C, we see the discontinuous, right? Well, if we just make it exactly as it is, of course, it will be impossible to compute the area, right? But then, because we have this improper integrations, because we have this method using limit, at some point, this discontinuous, we can approximate, and we can limit this continuous and make it a convergent value that we can compute. Okay, but of course, this statement C, they need both of the integrations from A to C and C to B, both need to be converged. If one of them diverge, then it won't make any sense. Okay. So that's all the type. Okay, type 1, type 2. And then one more section on the improper integral is we call the comparison test, okay, or comparison theorem. So sometimes we are not necessarily need to compute the value of the converged integral, but we can also just try to make out whether it's diverged or converged. Okay. So if the question is just asking diverged or converged, we can compare the integral based on the functions. Based on the function, we can see after this part. Okay. So basically, either type 1 or type 2, if you need to make sure your convergent or divergent integral, at least you need to make sure two steps. The first step is the integration itself. You need to compute the functions. Okay. Maybe compute the indefinite one first before you compute with the improper integral, so that you know that you can integrate that functions first. And the second part is using the limit. Okay. You input the point, input the limit, and make sure that you know whether it's diverged or converged. Okay. So at least two steps. Okay, because I think we need more practice and exercise. I think I can give you some exercise for chapter 7, including the improper integral. And maybe some part of it I will give you as an additional video for you, like a bonus content for you to practice. Okay? So I believe that you might need that. Okay? Yeah?
Is it next week
Wednesday?
Wednesday?
Yeah. Later I already talked in the early class, but I will talk again later, okay? So my plan today is giving all the last sections on chapter 7. And actually, I'm preparing some introduction on chapter 8. Just a few descriptions. Okay? Just chapter 8 is, in your textbook, it has like 5 sections, but I need just 2 sections. Just small sections. Because I think if you ask the professor in NTUST, especially when they teach calculus, they always need to make additional weeks. I can guarantee that. Because the calculus is set up not by the department, but by the college. So the college, they set up the contents, requirements, what the students need. And every year, we don't always have time. All professors that teach calculus. So that's also a problem. Because for me personally, the calculus, I think too much content for me. Well, if you compare to other university, like in United States or maybe in Europe, I think the contents in Taiwan Tech and maybe in other universities in Taiwan, the calculus part is a little bit larger. So that you should have 3 calculus, but we only have 2, but the same content. So it's like you squeeze these 3 calculus into 2 calculus. Okay, now let me give you first another theorem, okay, that we call the comparison theorem. Let me give you the theorem first, and then after that we can have maybe some example. The theorem is that when we have a functions, let's say we have f and g, both functions need to be positive functions. Okay, and then we have 2 statements. Okay? We have 2 statements, and you need to be careful on this too. Okay? The first statement, if integrations f from a to infinite, if it is convergent, okay, of course, below that f, which is g, the integrations will also converge. Okay, so f converge, then g converge. Okay, but the second statement you need to be careful. Okay, because most mistakes this happen on the second statement. If g divergent, then for sure the f that is higher than g will be diverged. But then you will asking, if f diverge, how about g? No, right? Okay, keep that in mind. Okay, keep that in mind, because sometimes in some problem solving you will get mix of that. Okay, but I believe that makes sense, right? That makes sense. Okay, for example, you look at this graph. If, for example, the g that's below f, if this is already diverged, then for sure the function that's higher than g will also be diverged. Okay? Okay. But if your f is converged, then your G also converge. And why do we even need this comparison here? Because sometimes there are integrations that might not as easy as you compute them, but you can predict whether it's converged or diverged by comparing with other integration that we can predict the results. So how we are going to use this is if we have an integration, improper integration that is unknown, we need to know whether it's converged or diverged. We can think other integrations that we can compare easily, that we can prove that, okay, f is greater equal g, or whether this is your unknown or this is your unknown. As long as you can make this comparison, and then you can find out your other integration easily, then you can use these two statements. Okay? You can use these two statements. Okay? So first, to use this is make sure this inequality. You can prove that. And the second, you can go to this statement. Okay? Which one is suitable for that condition? Okay? Okay, for example, let me just go for a small example here. Okay, so you have this integral from 1 to infinity, x over x cubed plus 1 dx. The question is just asking convert or diverge. It doesn't need to be computed. Like if convert, what's the value? Not necessarily important for this question. This is just asking convert, diverge, which means we can set up some other integrations that can be easily to be evaluated. Okay, so we have x over x cubed plus 1. Now what's the idea here? Let me write this as functions. So this is our functions. Okay. Okay, we have x at the top and x cubed on the bottom. We can say approximately this could be a little bit similar if we write one over x squared. Okay. This plus 1 you can ignore. Why? Here's why. Because we know that 1 over x squared is for sure greater than this. Agree? You can check. Agree? Agree? This is just a constant. The more you have, the less the amount is. Okay, the less the value. Which means 1 over x squared is a good comparison. It's a good comparison because we can evaluate this easily. And we know that from the 1 over x to the power of p, the p fast value, we can write here. So we can write to solve this. So consider 1 over x squared as a comparison. And then we can make sure that this is true. Okay, this is true. And then we know that this 1 over x squared dx is converged, right? Remember that when we have, let me write notes here. Note that when we have integration from 1 to infinity, if p is greater than 1, then it will be converged. If p is less equal 1, this will be diverged. This is from yesterday's class. So by comparison theorem. Because we know that this integration is converged, and this is greater or equal than this function that we are going to evaluate, then by comparison theorem, the unknown functions is, by the improper integral, is converged. Okay. Okay, so not necessarily need to compute the exact value, like how converged is converged. That doesn't need to be computed. If the question is asking just asking about whether it's converged or diverged. So our goal is to make sure that we know whether it's diverged or converged. So this comparison theorem is simplifying our predictions. But if the question also asking, then maybe you need to compute that. So one type is integration from 1 to infinity, the infinite intervals. Another type, probably you could check. Okay, you could check how's the, if you have 1 over x with power of p, if you integrate from 0 to 1, of course there will be some discontinuity, right? Okay. Because of this interval. Okay. So similar to what we have yesterday, we could also check what kind of p that makes this 1 over x converge and makes this 1 over x converge. Is it similar to what we have? Yes, yes it does. So we could write this. So this is additional notes. Okay, additional notes here. I will write here. Additional notes. Notes here. Okay. So we can take the limit. Okay. And because in 0 we have a discontinuity, then we can take a dummy variable to change the 0 and take it as closer as to 0 from the right side. And then I will directly integrate this 1 over x with power of p, similar to what we have yesterday, x 1 minus p, and then 1 minus p. Okay. And then plug in t to 1. And we are going to have 1 over 1 minus p as a constant, and then we still write limit as t approach 0, and I plug in 1. We are going to have 1 minus t 1 minus p. And then from here we got that 1 minus, I will make it into a fraction, so 1 over t, now p minus 1. Okay, I've changed this to p minus 1, okay, because of our fractions. Now from here, we could take p, let's take the p that is positive, or p greater 1. Okay. So p minus 1 is positive. So when we have this, then we have t p minus 1 is going to be infinity, right? When p is positive. Because t is 0, okay? So if you imagine p is positive number and p is 0, so 1 over 0 is infinity, right? Okay, so that's the first. The second, if we take the p is less than 1, let me move a little bit to the left side, okay? And the other part, let's say p is less than 1. So when p is less than 1, so p minus 1 is less than 0 or negative. If we take 1 over t p minus 1, if p is less than 1, it will be a negative. T power negative is 1 over something. Okay? And then when we take this to the t here, we take the 0, it will be a 0, 1 over infinity 0. So it will be converged. Okay? It will be converged. So we say that this will be diverged, the first one. The second one is going to be 0, or we say it's converged or convergent. When p equal 1, you could check p equal 1. It's 1 minus 1 is 0, so it's 1. So it will be p is 0, 0 with power of 0 is indeterminate form. So I think we just take a look at this 2 parts here. Okay, just an additional notes. Okay. Okay, let me give you one example. Okay, let's say we just want to compute, or just to determine, is it converges, diverges? Oh, by the way, when p equal 1 is for sure it should be converged. So you can write this also when p equal 1. I forgot to write here. The result is divergent, because we only need to see from here. result will be. Or you could check when p equal 1, you could also check integration from 0 to 1, 1 over x dx. The result should be also divergent. Okay. Okay, now we have this. Okay. Secant squared x over x square root of x. Now sometimes along the line, there will be some questions that just need to be answered by convergent or divergent, not necessarily to be the numbers. Okay. So what you need to do is one method using the comparison theorem. If you have this, what kind of functions that you need to compare with? So we have this, let me write here. So we have secant squared x and x squared of x. Okay. What kind of functions that we can compare with this? Anything in mind?
Trigonometric? No.
No? No, why we need trigonometry? Because we have this secant?
Must be.
Let me ask you, what values of trigonometry that need to be maximum? What's the maximum of the secant? 1, right? And it's squared. So it's kind of a negative. So it's supposed to be positive. So we could just ignore this secant. Because we know for sure the maximum value is just 1. Okay? So we focus on this x squared of x. So why don't we take that as our comparison? So let's consider. So we need to consider and then we can also write this as 1 over x with 3 over 2 as power, right? And then we could write the comparison between this secant squared x over x squared of x and 1 over x squared of x. And for sure, we could say that this is true. And we know that when we have 0 to 1, 1 over x with power of p, this will be when p is greater or equal to 1, this will be diverge. And when p is less than 1, this will be converges.
Actually, isn't it the other way? I think that 1 over x square root x is supposed to be always larger than, not larger or equal to secant square, because secant square can be equal from 0 to 1 and 1 is always 1. So it's supposed to be larger than.
Okay, wait.
Oh, okay, yeah, I guess yeah.
Do you get it?
Yeah.
Okay. I think you can also try to maybe more clear understanding using graph. I think that will be really convincing. Yeah. Yeah, I think if you draw in the graph, you will see that the 1 over x square of x is going to be. Let me just show you the illustration on the drawing. So this will be, let's say, x squared of x, and the secant squared is going to be like, okay, yeah, maybe not really precise, but it's supposed to be. So as long as you can prove the inequality, and then you can also find out other comparison that's easy to be evaluated as an improper integral, you can try this method, the comparison tool. I think to finish off, I haven't given you example from the last part, the type 1, type 2. Let me give you example on that, and then we can discuss the other part. Let's compute this. Okay, to get these questions, if you're not careful, you can integrate this. You can integrate by parts. You get the result. You put the number inside, and then you get the answer. But that answer will be wrong. Because this function is a continuous at 0. So, aside from the integration by parts, we need to write the limit. Using this 0 change to other variable like t. So you need to be careful. So now, because of the improper integral, you need to make sure, if you want to integrate, and you have the definite points here, you need to make sure that the points or the function is continuous. If not, then perhaps you need to use the limit. Okay? So we have additional limits to check the solution. But of course, like I said before, we have two steps, right? The first step is the integral itself, the techniques. The second one is the limit. So you can separate this as a two different process, and there will be two different points also if you get this as an exam. So first you need the techniques to solve. You get the. So for example, you could get this first. Maybe you could write first with the limit. At least you get this idea. So you can write this first. And then somewhere else within your paper, you could just integrate this without any integrants or anything. So you could try that as the first steps. So try evaluating just the function itself. But I think the technique itself needs time. So, okay, let me give you a couple minutes. Try to solve this using integration by parts. It can be solved using integration by parts, but before integration by parts, you need to rewrite the form first. And to rewrite the form, you can arrange using substitution. It's a little bit complicated, but when you see the way, you will get the pattern. Okay. What I mean is, I think the problem is this 1 over x. This kind of makes this integration seems impossible to integrate. It's because of this 1 over x. Well, you could try directly integration by parts, but my suggestion is to rearrange the form so that you can see the integration by parts with a more simple way. Okay, so let me write this. Okay, let me give you the idea here. I think we can take a break and have a discussion after the break. Yeah, we can have a break. Okay, well, I'm just writing some notes here. You can take a break. Okay. Okay, now I think we can try to finish off this part. So the idea is making the 1 over x as our substitution, and then separate this x cubed becomes 1 over x and 1 over x squared. Because 1 over x, when we differentiate, it will be this x squared, right? We can substitute this dx, and we get nicely u e part of u, and we can integrate it by part easily, right? So we can integrate by part. This will be u minus e u, and this will be e with power of u minus u e u plus c. Okay. Now, if you are confused on how we get this, we can try to take this as integrations, as derivative, and this is integrations. So u differentiate with respect to u is 1, and then differentiate again with it becomes 0. So plus minus plus, this is the same, e is part of u, and then cross multiply. And we get this as the result, and this result will comes in handy when we calculate the limit. Okay. So this is the first step: calculate the integrations using some techniques, and then we can go here. Let me write in here that we have limit st going to be 0 from the left. Okay, now you could take back this u, right? The 1 over x becomes the x, right? Or this part change to u. So you can do both. But my suggestion, because if you change this u back to 1 over x, there might be some confusion on the calculation, maybe some difficulty to calculate. Maybe we could just take this 1 over x into u. Okay, so we can change all the, it becomes u. So if we take that, it means that we are going to change the integrands. Okay. So let's say this is going to be negative u e with power of u du. To write the integrands, remember our substitutions. Our substitution is u equal 1 over x, right? So when x is negative 1, u is the same, negative 1. When x is now t, then u will be 1 over t. Okay? So that's what we are going to write in the integrand. So this will be negative 1. This will be 1 over t. Okay, and then we can write, still writing the limit, and then we can write the result from our integration. This integration we can write here without the plus constant. So we could write that. This will be e with power of u minus u e power of u. And then input the integrands, which is negative 1 to 1 over t. And then let's input 1 over t. So 1 over t minus 1 over t, or 1 or e 1 over t over t. And then minus, let's input negative 1, e negative 1 plus e negative 1. So let's write, still write the limit. I think I can write a little bit left from here. So let's write, let me write the constant e with power of negative 1 in the front, so negative 2 over e. Okay, and then plus this part here, I can write e with power of 1 over t, and then we can write 1 minus 1 over t. And then still this negative 2 over e, and I will multiply with negative and change the inside functions. Okay, let me resize all this, make it a little bit smaller. Okay, so we have this e with power of 1 over t, and then multiply with 1 over t minus 1. Well, if you take this inside here, but I would like to make this into more simplified so that we can observe clearly. So let's say we are going to take this 1 over t. So we let this 1 over t becomes another variable s. Okay. So when t is going to be 0, this s will be going to be negative infinity. Remember, the 0 is from the left. So for 1 over t, that will be negative infinity. So we could take the limit now, changing to s, approach negative infinity, and then this is the same, and minus. Now it's become e with power of s, and then s minus 1. And then I think we can take out the negative 2 over e because it's a constant. So let's just take it out, and then minus, and then write the limit. And then we can write the s minus 1 over e with power of negative s. And then what will happen? You can take L'Hopital rule. So take L'Hopital rule. So this will be negative 2 over e. So L'Hopital. So without giving you like, okay, final exam is only the second half, but actually that's linking to the derivative also. Okay, and then limit, still have limit. And this become 1 or even negative. And then this is having negative s. And this will result in 0. Because remember, we have negative here, so the negative cancel. So this is infinity. So we get 1 over infinity. So 0. So the result will be negative 2 over e, and this will be converged, right? Convergent. Yes? Yeah, but still the same. Oh, okay. All right. Okay, I think at the beginning I said that we're going to have a chapter 8. Okay, after everything, maybe that will be on next third topic. So you have some additional content for Congress 2. But I think for that part, with chapter 8, I will just prepare a video for you for next semester. I think since you have a heavy burden. So officially, then our chapter is finished. So maybe we can have some practice or exercise. Okay, maybe before we continue, is there any questions? So I think I can discuss, as I mentioned earlier, that since we are officially finished the chapters, so we can take final exam anytime. For me, anytime is okay. But the problem is I think it's you. I'm not sure your schedule, so I will let you to take votes. I will take some polling in the feedback. I will use that feedback as our final decisions for the final exam schedule.
Basic final exam Monday. Basic. Yeah, physics final exam is on Monday.
And
We have physics next week.
how about chemistry?
So it's chemistry.
Friday? Oh. So if I take maybe maybe. But do you prefer morning or morning class? I think you can just wake up early, still focus.
But this kind of weather is hard to wake up.
But you're not sure yet you will be able to wake or not, right? When you wake and then, oh, it's afternoon. It's like calculus. Okay, well, let me give you more examples. More examples. Okay, just two integrations. So if this question's only asking converge or diverge, and perhaps the comparison is the way to check. And you could also check the other questions as well. Let me write here. Determine converge or diverge. If converge, compute the value. Okay, I think it's not that complicated to integrate the integral. You want to try? So the first part here, it will be using. It's going to be using the conversion theorem. So the way we see the integral, we always see what possible value that could be determined from the function. What's the maximum value? When you find out the maximum value, then you could consider other functions that you can compute easily. And perhaps, I think we haven't yet had the some 0 to infinity from this function, right? From a function that can be rated here, from probably the function related to E. That one, you need to prove that also. So find the function that seems simple and can be integrated, and you can prove that whether it's divergent or continuous. I think for this part, you could see the takeaway is this x power 4, and then you have square root. And you could consider what kind of function you want to compare. Because when we have the square root, perhaps this is going to be similar more or less with x squared. Right? And x squared and x, or perhaps it's going to be having to compare with 1 over x. Okay, and then you could prove the inequality, whether it's fit in within the theorem or not. And then for the tangent inverse, if you're not sure what kind of graph that we could have from tangent inverse, if you know the tangent, if we have like this, right? And have the asymptote, we rotate, that will be the tangent inverse. But we are just going to be having the limited domain, right? With the limited domain. So you can imagine what kind of maximum value that the tangent inverse will have. But if not, then you can just type in your go to GeoGebra or Desmos and try to look at it by yourself and convince yourself, okay, then perhaps that will be supposed to be that the tangent inverse cannot be going above that value. Yeah, perhaps it's supposed to be going to be 1 point something, but if you think and you look at the graph, the tangent inverse will not going to be above 2. It's always below 2. So we could just say that 2 will be, the tangent inverse x will always less than 2. We could say that. So that's 2, we can write in the consideration into our other functions that is always less than 2 over that. So we could first try out and then convince yourself that this tangent inverse is going to be less than pi over 2 and also less than 2. So we could take this 2 for our other function that need to be compared. So we could write the tangent inverse over 2 plus e with power of x. This is going to be less than 2 over 2 plus e with power of x, right? Okay. Based on our deductions here, we could write this. And then we can simplify this into more other comparison, that this is going to be less than 2 over e with power of x. Okay. When you have a constant in a fraction, when you add constant in the bottom, it means that it's going to be less. When we have greater constant, we will less. So what we are going to focus, let me give you my suggestion and tips. For the comparison theorem, focus on the function. I mean with the variable. The constant, you can not ignore, but you can think the constant is not that impactful for the comparison. And you can, let's say, ignore that. And then we can write this 2 with over e to the x. And this is, I think, quite impactful. And I think if we integrate this from 0 to infinity, it's possible. Right? It's possible. Right? Well, you could try other way, like maybe other function that can be also integrated. Right? It's up to you. What kind of function that you want to compare with, as long as that function is going to be able to be integrated easily. So let's use this and take that as integrations. So we are going to integrate from 0 to infinity of 2 e with power of negative x dx. And of course, this will be improper. So we are going to take limit. And the integration of e with power of negative will result in a negative form, right? And then input 0 to t, and then this will be equal to negative 2 over e with power of t plus 2. So based on our limit, this will be converged, right? This will be converged with the value of 2. So converge. since this converge, then our tangent inverse over 2 plus p with power of x also converge. So, based on comparison test, also converge. I think I will give you this, the second one, okay, by yourself. Okay? I trust you. Let me give you a clue. Let me give you a clue, and then you can try that one. This one, consider x plus 1 over square root of x with power of 4, and this will be greater than x over x squared, okay, and this will be 1 over x. Okay. And to make sure that this is correct, the inequality, you can check that out. Okay. Prove this inequality is true, and then after that, you can check the 1 over x, and since we already discussed 1 to infinity or 1 over x and 1 over x in general with power of p, we could take that as our proof. So in your exam, for some parts that we have known already, you don't need to prove that anymore. Like for example, if you have 1 over x with power of p, we know that if this is going to be integrated from 1 to infinity, if p is greater than 1, for sure it will converge. If it is less or equal 1, then it differs. No need to prove that, okay, this is correct. You can directly write the final prediction. But if it's something that maybe like this one, you are not familiar with that, then perhaps you need to try. Okay, the last two, I think you could try to integrate first. Okay? Try to familiar with the techniques. Okay? And after that, you could use the limit to take this infinity and change to t. So I think you can try this first. Try it. My tips for final exam preparation is to learn math is by doing math. Do not like read, useless. But doing math is what matters. So when you have some concept, try to write something. Even when you write notes again, not in class, like you write again, like summarize everything in a more clear way, you will learn twice. And I think that will be helpful. So if you just take notes in class without ever take notes again, or try to, if you just read out your notes, I believe maybe just 50%. You will learn just 50%. But if you try to write out the notes and then maybe something or maybe some question got pop up in your head, oh, why I'm writing this? When that question happens, it means that you are learning. You learn that, okay, I don't know this part. I need to know this. I need to know this. And that's where you are learning. If you just like reading, passively reading, it's just 50%. But when you are trying to make your notes maybe more clear, clean, summarize again everything, like maybe writing the whole notes into maybe short sections, I believe that will be helpful. That will be helpful. And if you try to teach your friends, you as a teacher will learn twice. The impact will be twice. Okay? So after you got something, and then your other friends asking you, try your best to teach them. If when you are teaching your friends, you get stuck, it means that you still not understand that part. Sometimes we understand, like we think we understand, but actually it's not yet fully understand. Maybe only 60, 70%. To know that is to try your limit, to test your limit. Okay? Test it out by teaching your friends. If you still cannot teach them like in a proper way, then perhaps there's something wrong in your understanding. Then you need to relearn again and again. It's like a repetition, like an iteration, like a machine learning process that you could try and error. But for that process, the process itself actually will help you to grow, not only for this course, and also it also grow with other courses as well. If you can sum up advanced learning process in a more proper way, simple, and everyone can understand it, you are a good teacher. And that is twice impactful as just doing passive reading. Okay. Okay, I believe this will be the end of our class. And officially this is the end of a class. Okay? So suppose we are not having any more classes. The final exam can take any time. Okay? Like I said before, the time is not my problem, it's yours. So I believe giving you decisions will be the best choices for this class. Okay? Because you have a vote for your rights. Okay. So I will prepare some polling in the end of the Mentimeter, the feedbacks. But we have the feedbacks first, okay, as usual. And depends on what feedbacks you will read on. I'm also going to prepare additional content for you to learn and study, okay, at least for final exam preparations, okay. And I hope my additional content will be going to be helping you along the way. So this is supposed to be the chapter 7. So including the techniques, I think some parts about the proper. I think 3 questions. 2 simple questions and 1 a little bit longer question. Okay, so if everyone already join in, wait, where is this button? Oh, this one. Okay, I think we can move to the next slide. And then write your student ID or any nickname, but let me know your nickname at the end, okay? Although it's just a small percentage, like a really, really small, but I hope it could help the decimals part. If you have like maybe a little bit going to increase your grade. Okay, I think we can start. 3, 2, 1. They would like to know the reason. Okay. 50-50. It's false because the numerator is x cubed. It's x cubed. If you divide, and it will be long division, and it will be different forms, right? Yeah. Okay. Number 2. I also forgot what the question. The number 2. Oh, still true or false? Okay, it should be easy. Just give you less than 1 minute. I think I already repeat all over the time. Or you can just take notes. Look at your notes. Maybe the question, what is square root of 2? Maybe some of you have forgotten what is square root of 2 and write the wrong answer. I think the number 3 need to have some calculation. A little bit longer, maybe 5 to 6 minutes. Okay, it's true. Because it's 1 over x to the power of p, the p is greater than 1, right? Okay, still the same. Just change for a while. Okay, go. 8 minutes. 8 minutes. 8 minutes. So you can optimize your calculations. Well, there is a shortcut if you want, but not sure that will convert to the options here. But you can try using the website or from our calculator. But probably you need to, well, it depends on your calculator. In your final exam, I will allow calculate. So that means the question would be. But still okay. Although you're using calculator, it's just confirming your answer. Like the computation in the area, volume, that sometimes you need to write the final result. Oh yeah, it's x cubed, so you need to separate nicely. There is a trick for factorizing the denominators. I think I've shown it before, but I forgot this class or other one.
some trigonometry. Yeah, no, don't wait. Trigonometry goes with you. Okay.
Yeah, this is I think substitution. Trigonometry substitution, but that will be last part. First part is the partial fraction. This is just testing type of question. You can use time to
So we're allowed to have our calculator in like that?
Yeah. For final exams.
Yes.
Oh, you were supposed to ask. Why don't you ask? So yeah. So this question, perhaps you need 15 minutes. Yeah, I'm just averaging your time. So this is for consideration on some exam questions. So that's 8 minutes. So maybe 5 to 10 minutes. 5 to 10 minutes is the observation, and another 10 minutes the algebra. Yeah, 15 to 20. No mistake in computation, maybe. Yeah. Okay. This is my consideration for taking the question into the exam. How many minutes usually take. And we'll conclude like how many questions I need. I think you can confirm using the Wolfram Alpha. I think maybe we'll give you the final result. I think Wolfram Alpha will give nicely this product. Okay. Diverge or converge. Who is Diverge or Converge? Okay. Why you always take unique name? Okay, Thomas. Congratulations. Okay, polling. No one morning class? Okay, so for all students, you get the final exam on that day. If you have any problem with the schedule, like maybe that day you need to take early, let me know, okay? Maybe you already have planned for booking flights or maybe booking some tickets to go. Let me know. You can have an early. And any suggestion? Like to write, and that will be the end of our class. Jadinya gimana? Divert? Kayaknya iya bener ya integralnya.
Kenapa ini perbandingan
Enggak. Nah,
kalau dibikin komparasi
nggak pakai comparison, hitung aja. Coba hitung aja, bisa nggak dihitung? Kalau ini kan nggak, belum tentu kan? Iya bisa. Ini kalau nesnya di bawah.
kalau yang ini
Itu divert kan?